Hello, everyone. My name is Nanli. I'm from Ghent University, Belgium. So today, on behalf of my co-authors, I'm really happy to present our work FEIR, which provides a new way of thinking about fairness in recommending limited resources. So yeah, just as our lovely first speaker, Amanda said, fairness is not one-dimensional. Fairness has many different definitions. So here is our take of it. So to understand the problem, perhaps we can begin with thinking about recommenders for movies or music. You know, those recommenders we are more familiar with. I mean, well, everyone has worked with movie lens before, right? So there, the atoms have unlimited availability, where there's no problem just recommending the same atom to many, many users. But the case is different for limited resource recommendation, such as jobs or education resources, where users typically need to compete with each other. So the problem with the current practice, the so-called top K recommendation, is that it only cares about utility, but ignores competition completely. Typically, we just compute some sort of relevancy scores between users and items, then recommend each user the top scored items. So the result could be some popular jobs would be recommended to a lot of users. Then most of them will lose during the competition, which is also kind of unfair if you think about it, because they basically are wasting their time and energy to compete for something they never stand a chance for. So to solve this, well, first we need to quantify exactly what we mean by competitive disadvantage. That's why we introduced the first new fairness matrix. We call it inferiority, measures a user's competitive disadvantage. And we combine it with another individual level unfairness matrix existing in the literature called envy, which measures how much a user prefers another's recommendations. Then, like everything in life, there must be a trade-off. Imagine some dream cases. If we give everyone the same job, then there will be no envy because everyone got the same thing. But it will cause high inferiority due to the intense competition. But on the other hand, if you just give everyone different jobs, then there will be no competition, hence zero inferiority, but it will likely result into high envy and low utility. So that's why we introduce our method, FEIR, which is short for fairness through envy and inferiority reduction, which is a model-agnostic post-processing method, takes the output scores from any recommender systems and adjusts the recommendation to be fairer. To be specific, we created differentiable probabilistic versions of the three metrics we care about: utility, envy, and inferiority. Then we combine them into a multi-objective, a huge loss function. Then we can just, since the math is smooth and solvable now, we can just use standard gradient descent to find new recommendation probabilities that optimize this trade-off. So we did a bunch of experiments. We used both synthetic data and real-world data, and we compare FEIR with 4 baselines. Let's see some results. Since this is a multi-objective optimization problem, so we plotted Pareto frontier. As all these graphs shows, the y-axis is the utility, so higher is better. The x-axis is the unfairness, so lower is better. This means the upper left corner is the ideal situation. So each dot represents a different solution achieved by a different level of trade-off. And each color represents a method. So our method is the blue one, which consistently provides a superior set of solutions. So to sum up, we identify a new problem and we solve it. I guess the takeaway is we should be more mindful of the competition in recommenders. And our method is effectively solving this But yeah, this is just the first step. But I hope everyone can, take some message from it and be like more careful about this. So thank you for your attention. Now I'm happy to take questions if you have time, but you can find me later if you are interested.
Thanks for the talk and this
you.
interesting work. Could you say a little bit more about this inferiority metric? How do you determine what somebody's sort of competitiveness is? Is that different for each user, or is it just a function of what kinds of things are recommended?
Yeah, it is. This is an individual level fairness. So actually, you need to compare each pair of users. Say I am one of the users in the system, and all of you are, the other users in the system. Then to compute my competitive disadvantage, I need to compare myself and everyone here. So first I need to see what are the items being recommended to both of us. Then I check whether you have higher suitability to the items being recommended to both of us. And if you have higher suitability, then I have some sort of degree of competitive disadvantage.